Okay, so let's look at another. Let's look at 56. On the same page, 137. G of x equals x cubed, or 3x minus 2. The first branch for x less than or equal to 1, and the other branch for greater than 1. Two questions. Verify that g is continuous at x equals 1. Is g differentiable at x equals 1? Why or why not? So part A, g of x continuous at x equals 1. Would you agree that x cubed is always continuous and 3x minus 2 is always continuous? Why? Because they are what type of functions? Polynomial. Excellent. But I don't know if this function is continuous at 1. How do I check? What do I have to write and determine before I conclude yes or no? I have definition, please remember this, of continuity at a point. Definition of continuity at a point. We can't forget this one. I think we wrote it like 4 times already. Let's write it again. So limit as x approaches from the, good, from what?
From x cubed.
Excellent. Must equal, I don't know. I'll put a question mark on top. Must equal, limit. As x approaches 1 from the right, yes, from, very good. And it has to equal
The same thing.
what is the third?
Oh. F of 3.
F of, we are discussing continuity at 1.
F of 1.
Perfect. Good. So please give me the left one. Please give me the right one.
1.
And please give me f of 1. Tell me which branch you are going to use for f of 1, top or bottom. Good. So what is f of 1? What do we conclude? Continuous at x equals 1. Therefore, f of x, g of x, I'm sorry, g of x continuous at x equals 1. Good. So now part B. They're asking us whether is g differentiable at 1. Why or why not? Remember, continuity does not guarantee differentiability. What do I have to do? One way would be to graph it. Second way would be to determine the derivative from the left, which is the slope on the left. Determine the derivative from the right, which is the slope on the right, and see if they're equal. So let's determine the slope from the left, and let's determine the slope from the right. How do I determine slope from the left? How do I determine that? I know how to determine, let's go back for a moment. I know how to determine the slope from either side. This is the slope of the tangent line from either side. But how would I determine the slope of the tangent line from the left? H approaches 0, right, from the left, of f of 1 plus h minus f of 1 over h. How will I determine the limit from the right? H approaches 0 from the right, from f of 1 plus h minus f of 1 over h. Another way would be to find f prime for both functions. F prime of x. and then plug in 1 and see if they are both the same. It's another way. So let's go with this one. So limit as h approaches 0 from the left, from f of 1 plus h minus f of 1 divided by h, which is with a different, totally different function. Now the slope, and we'll calculate in a minute, from the right. How will I determine the slope from the right?
The limit is h equals to 0 plus is f of 1 plus h minus f of 1 over h.
Yes, they will be different because I have to use different functions. One from the left I will use x cubed, and one from the left I will use x cubed, and one from the right I will have to use 3x minus 2. So they will be different, although the definitions are the same except 0 from the left or 0 from the right, but the functions will be different. Very good. Now the first one is not that friendly. So limit as h approaches 0 from the left, from x, I didn't mean to write x, I meant to write 1 plus h. 1 plus h to the third minus 1, I'll erase that, over h. Because, are you with me? Any questions, please stop me. The function from the left is x cubed. So, yes, please.
Normally in the original problem, it's f of x when we have negative minus f of 1. We don't have to plug 1 into x, so 1 to the third to get 1, do we?
Oh, but it's 1 cubed is 1.
Okay.
I'm sorry, I should have mentioned that.
But normally you would, right?
Yes.
You have to
Yes,
plug it
it's
into
just
the
that it happens that x cubed
was 1.
with 1 cubed is still 1.
Okay.
Yes, of course, of course. So this is f of 1. So for example, in the second one, it happens that f of 1 will still be 1, as we know, because we just determined it.
Gotcha.
But yes, you will have to plug in the function 1. Good. Okay. So first, this is a limit, and I have to determine the type of limit. What is it? If it's 0 over 0, then I know how to proceed. I know that the limit has hope.
So the x is 1 plus h.
No, that's the difference coefficient, f of x plus h. But now x is 1. F of x plus h minus f of x over h. But now x is 1. And the function is x cubed. So then that's why I have 1 plus h to the third. So the function is x cubed. So I have to plug in x plus h cubed, but x is 1. Better? Good. So is it 0 over 0? When h is 0, 1 cubed minus 1 over 0, right? So it's 0 over 0. How do I proceed? I have two options here. If we remember the difference of cubes, we will use the difference of cubes. If we don't remember the difference of cubes and you don't want to go that route, then we have to cube this. Which one you prefer?
Can we cube that?
Yes. That's fine. So 1 plus h to the third is 1 plus h squared times 1 plus h. And this I have to know from the very first day of classes. So this is 1 plus 2h plus h squared, and this is 1 plus h. And now I will distribute 1 to these three terms, and then h to these three terms, plus h plus 2h squared plus h cubed. You don't have to memorize this, but this is done also with in other methods. So it's h cubed plus 3h squared plus 3h and plus 1. We do this in other classes in which we show Pascal's triangle or combinatorics to get the coefficients. Okay, so now we have 1 plus h cubed. And here it is. H cubed plus 3h squared plus 3h plus 1 minus 1 divided by h. what has to happen every time I look at it or work with the difference quotient? What is the first thing that has to happen?
All the non-H terms.
That's what I expect. And then eventually the h from the denominator must go away. So these two go away. Limit h approaches 0 from the left. And of course, I will factor out. What will I factor out? The greatest common factor, which is? Of course. So this is h squared plus 3h plus 3 divided by h. We're happy. The problem is gone. And now the limit operator can be dropped. And the answer is?
H squared plus 3h plus 3.
Can be dropped. Once I drop the limit operator, it means that I plugged in h0.
Oh,
It's a polynomial.
3.
3. Awesome. Done. Let's repeat for the other one, which is much easier. So now I would like to determine the limit as h approaches 0 from the right. Again, from f of 1 plus h minus f of 1 divided by h. But this time the function is a linear function. So it's 3x minus 2. Okay, so can anyone dictate?
3 times 1 plus h.
3 times, you want to put parentheses then?
Yes.
Well, that's fine. Minus 2, and we know that f of 1 is 1 divided by h. Perfect. So this is limit. H approaches 0 from the right. 3 minus 3h minus 3 divided by h. Every time we determine or play with the difference quotient, all terms without h at the top must go away. So this is limit as h approaches 0 from the right from negative 3h divided by h. H go away, so the limit is
Why is the 3
Why should 3
negative?
negative?
Oh.
Sorry.
all of a sudden. Thank you, thank you, thank you.
It's 3.
Good. Okay, what do we conclude?
It is differentiable.
Yes, at 1, right? Because there is 1 tangent. This is 3, and on this side is also 3. It's not 3 and negative 1, or 3 and positive 2, or 3 and 1, or 2. So there is a unique tangent at 3, and its slope is on both sides 3. There is a unique tangent at 1, and the slope on both sides is 3. Therefore, there's no corner, no cusp, no vertical tangent. And I will say yes, differentiable at x equals 1. So this was a long process. Continuity was nice, right? We only had to determine the limit from the left, the limit from the right, and the function value. That was okay. But to show that the function is differentiable, we had 2 ways. You can simply graph it, but that will not give you 100% certainty that both limits left and right are the same. Or the second method is to break up this limit of the difference quotient into 2 pieces. The left piece from the first function and the right piece from the right function. Okay? Good. Any questions for me? So obviously now we are ready to put in the title. So the title of this section is differentiation using limits of difference quotients. So this was 1.4, and we'll practice some more. So 1.4, differentiation using the limit of the difference quotient.
to match the lid on the left. Which
Right.
is different.
Yes, for a unique tangent. Otherwise, it's like this, which is a corner.
And one can't be negative and one can't be positive.
No, they have to be exactly the same number.
Gotcha.
Exactly. Either this or this. Yes, there must be a unique tangent there. Yes. They may look differently. As long as the tangent is unique with the same slope, the function is differentiable there. Its rate of change at that point exists. It can be determined. And it happens to be 3 for this function. Okay, let's look at a few more functions that are very important. Let's say f of x, x squared. So for now, we know that f prime, when f of x is the square root of x, f prime is?
1/2 square root of x.
This has to be committed to memory. Okay, let's see the definition of finding the derivative of function x squared. Is x squared always continuous? Yes, it's a polynomial function. Is it always differentiable? I don't know yet.
Not at 0.
We have to see. If its derivative is defined everywhere, then the function is differentiable everywhere. If there is no restriction on the derivative, then the function is different. If there is a restriction on the derivative, like here, it's not differentiable at that point. Good. So how do I write f prime? I want to find f prime for x squared. Can anyone dictate?
The limit as h approaches 0.
X plus h squared minus x squared over h.
That's it. So we have to commit to memory the difference quotient. And for x squared will be x plus h squared minus x squared over h. We agree with this?
Yes.
Good. So you can use the difference of squares, the formula that we just reviewed when we applied, rationalized the numerator, or you can just square. Whatever you tell me, I will write it.
X squared plus 2 xh plus h squared.
Every time we play with the difference quotient, 2 things must happen, and they are
Anything without an h has to cancel out.
a top. Anything that has no h in it must go away. If other terms go away, it's a bonus. But I don't count on that. And then,
And then you have to be able to pull the h out.
correct? In other words, eventually this h must go away. So limit, sh approaches 0. What happens next?
2x plus h.
I simplify. And now I drop the limit operator. And I will know forever that x squared has a derivative, has a function that will give us the instantaneous rate of change at any point. And that function is? We are replacing h by 0. It's a polynomial. We are replacing h by 0 and we get to x. So from now on, we commit to memory that x squared prime is?
2x.
And here is a question for you. What do you think x to the third prime will equal to?
3x
3x
squared.
indeed. Okay, one more, and then we'll come up with a rule together right now. Let's say x to the nth power prime. Any power, what will that equal to? N times,
Times x. And minus 1.
that's it. So this is what we call the power rule for differentiation. So for any x, not a function to that power, we're not there yet. So x raised to any power prime or differentiated is n times x to n minus 1. So is there any restriction on 2x?
No.
So x squared is differentiable anywhere. Is there any restriction on 3x squared? No. So x cubed is differentiable everywhere. Any questions? Any questions? Okay, I would like to differentiate 1 over x using this formula. But I have to think what 1 over x is replaced or can be replaced by. And it can be replaced by x raised to, awesome. So please tell me now, what do you think this will equal to?
So -1
-1 multiplied by
x
x raised to
the -2.
-2. We subtract 1 from the power. We had power -1, we subtract 1 from the power. So this can be also written how?
-1 over x squared.
That's it. So this is another situation that we have to commit to memory. Another function. 1 over x prime is -1 over x squared. So now my question is this function differentiable everywhere where it is defined?
Yeah.
Yes. Because this is undefined at 0. It's not continuous. In that it cannot be differentiable. And they're not, here they're not additional, we don't have additional restrictions. So where that one is not defined, this one is not. It's okay. So this function, that function is differentiable everywhere on its domain. And what is its domain? Anything but 0.